Hello everyone. Today I'm going to do a talk about radio frequencies and sorry. Today I'm going to do a talk about radio frequencies, a bit of the legalities of it, about RTL-SDR and some other things. So let's start with what is radio frequency, or RF to be shortened. So it's a repetitive variation of alternating electromagnetic or mechanical system. So as you can see, there is a wavelength, so it varies from 10 kilometers to 1 millimeter, and it's an amplitude. It covers loads of sources used for different situations and appliances, such as submarines, radios, television, microwaves, satellites, Wi-Fi's, and the list just goes on and on. It has frequency, and different waves, different wavelengths and frequencies have different properties, which I'm going to mention in a bit. So where are they used? So yeah, it's radio frequencies. It's used in so many appliances that it's hard to keep track of at this point. It's used in satellites, radios, phones. So our phones are like little RTL-SDR modules, which are software-defined radios. So usually in a radio there is a chipset which has a lot of filters, amplifiers, antennas, and analog to digital transmitters, which is the main cost of the radio. So the stronger the signal is, which is considered to be measured in watts, and the higher the signal is, the more costly it is. So the main waves used for radio frequencies are VHF and UHF, which stand for very high frequencies and ultra high frequencies. So what they are, so very high frequencies are basically wavelengths which go for long distances, but they're not really good in urban areas because they're quite weak when it comes to penetrating surfaces such as wood, metal, and concrete. So they're really good for long distances in open rural areas because they reach long distances and they can curve a bit around the objects. And the ultra high frequency ones are better in urban areas because they're more dense amplitude and they're a bit shorter, so they don't reach as long distances, but they can get through the obstacles easier, so they perform better in urban areas and can be way more clear and beneficial in this regard. So what is legal and what is not when it comes to radio frequencies? So as a rule of thumb, you can listen to everything you get through the radio frequencies. I forgot to mention at the start that please be cautious how you use these kind of equipment and what you use it for. You can get into big trouble for transmitting some information on the channels you're not allowed to. We're not accounted to be we're not responsible for your actions. Basically, that's what I'm trying to say. So you are able to listen on all the frequencies you can access, but you're not able to transmit on some of them, majority of them actually, and you need a special license for that. So VHF bands which you're allowed to transfer are from 173 to 175 megahertz roughly. As you can see, VHF ultra high frequency bands are from 863 to 865 megahertz. Wi-Fi bands from 2400, and transmitter power are up to 10 milliwatts. So you're allowed to do all of these as long as it does not interfere with television reception for, it might be your neighbor, so as long as you don't restrict their transmission receiving, so you're good to go. So let's talk about software-defined radio, or SDR. So it's basically a module which, in a concept which I'm going to talk about in the next slide, works by creating a cost-effective solution to get as much of radio amplitude as you can. So SDR is it can usually be an USB chip with an antenna which screws in. It's basically an antenna which receives the data and transmits analog, which is casual wavelengths of frequencies, and transmits it into digital data, which we can plug into computer and read, and use software to filter it out the things we need. What can you do it? So as in cyber security aspect, you can do quite a bit of it. I'm sure you heard of the replay attacks. Majority of the cheaper ones can just receive, so they can transmit. But for example, the more expensive ones, as a hack or F1, it can transmit as well, and it has a bit of few other features. So you get some additional tools for paying additional price, but in general, you can get it quite cheap, just as an amateur to play around. But if you want to do it professionally, these tools can be very costly. So as I mentioned, you can do replay attacks on older cars to unlock it. They just press the key button on their car key to unlock it, and you can just record it and replay it the other time and unlock a car at a command. The newer cars have a thing called rolling code system, which is a bit more advanced from a previous one. So you can't play replay attack, but you can jam one signal, so I'll think, oh, it didn't work one time, the key, so it didn't unlock my car, so what are you going to do? So they're most likely going to press it again, and now you allow them signal to pass, and they just unlock a car. But you start the first signal, they pressed the button and you jammed it, so it didn't reach a car. So now you have one time open a car key, which you can use to unlock a car and gain access to it. But the jamming is another topic, and in general it's frowned upon because it can get very illegal. So I would advise not to go that way. And so SDR, software defined radio, is as close as it gets to cognitive radio. What cognitive radio means is basically like definition of a perfect radio. So there's loads of signals, waves, and other appliances around us that they start interfering with each other. So the signal might be disrupted, cut off, or just unclear, and with a lot of noise. So what cognitive does, radio, so as it's software defined, it can put loads and loads of filters on top of the signal and just filter out unnecessary data. It can be even used with AI to teach and learn to filter out unnecessary ones, so it becomes as precise as it can. So it allows you an option to have a transmission over long distances being very clear without any disruptions, just as clear as it can. So there's quite a few softwares for SDR, or software defined radio. These are the free ones I would recommend personally. They're the main ones. So we have GQRX, which is quite a nice one. So basically, as you can see, this is the frequencies you receive. This is the main line of frequencies you get, and these like bumps on top is the lines of occupied channels of the radio frequency, which you can just literally tap on, and you can adjust the line, this white line, and just listen to the channel and try to put some additional filters and clear out you can clear out the volume. So this way you can literally listen to police stations, fire stations, even catch up some satellite, airport. You can even make maps. I'll come down to a few slides down and I'll show you more of the properties. So RTL-SDR is another one nice use. So as you can see, it's just a different interfaces. They have some additional tools. Of course, these two top ones are the free ones. They're usually available on Windows and Linux, but SDR software usually tends to lean towards Linux because it's more oriented around that area. Studio One is a paid one. As you can see, there's loads of features, and this is more professionally based IDE for software defined radios. It has amplitudes, it has filtering. You can put different settings and precise data, which allows you to be more flexible with your research or just projects in general. Followed by that, so as I talked before, I wanted to mention how SDR work and with the channels. So the main thing, how did it come down to like being a $20, $23 or like 19 pounds, 20 pounds in British price, is that it wasn't initially, it wasn't as intended as SDR, but two professors and researchers managed to make it work like SDR. So initially it was like a channel distributor. It's like for TVs to get additional channels, you just plug it into a USB port at the back of it and with a little antenna, and it allowed you to get additional channels to be viewed in your television. So the main thing, what is the most costly in the radio, is analog to digital transmitter, so ADC. And basically it's at 20 megahertz range. So imagine this is a 0, and these are 150 kilohertz channels. So there are a number of it. So the 20-pound one could do only one or two, only a few, as RF hack one you could transmit all of them. So basically what this means that with one chip you could listen to a few channels, and with RF hack RF1, you could listen to multiple of them and just listen at a few channels and record few channels at the same time, while with a smaller one you could do only few. How did we make this more cost efficient is the higher the frequency, the more expensive it is to manufacture the receiver for it. So we came up with the idea to reach the 0 as close as possible, but as soon as frequency reached 0, these 150 kilohertz reach left and right, both directions, by 75. So this part of the frequency is transmitted to digital and is properly processed, and you can listen to it, but you lose half of the data because frequencies can get to negative values, so it just gets cut off. So what they basically did, they put this axis and 90 degrees, so it goes horizontally and vertically. So basically the well-known IQ differential is basically one half of a data, 75 kilohertz in this instance, would go horizontally and another would go vertically. That way we can read both, and we came as close to 0, so it's as cheap as it gets for analog to digital transmitter. So SDR applications, there's a huge list of SDR applications. As you can see, there is decoding aircraft ACARS, short messages, encrypting digital voice transmissions, scanning for cordless phones and baby monitors. So the possibilities are really huge, and it just comes down to creativity, how you want to use it. The main usages for it would be just out of curiosity, scanning what's around you. You can see what kind of services are being transmitted on information around you, and maybe have some fun with that. You can make scannings, and you can make maps around you of radio frequency data you receive around you, and you can just start tracking over what's happening and just making radio frequency maps around you. You can receive wireless temperature sensors and wireless power meter sensors. So another thing is, we talked about RFID scanners by the doors the other week. So in theory you could scan, you could catch the frequency of them, but the thing is that we operate in very short distances. So if you're like kilometer away or even a few hundred meters away, you won't catch it, the signal, because it operates in very close proximity. So that's why the cars are nearly touched in contact with it, just to work that way. Another things you can do with radio, software-defined radio, is characterizing RF filters and measuring antennas, WR, Use RTL-SDR as a noise figure indicator to see how much interference you get with other objects on your in your house, proximity, or a flat. You can decode taxi mobile data and terminal signals, listen to and decode the HD radio, listen to open source radios. The list just goes on and on. But what I would personally recommend is if you decide to use RTL-SDR radio, software-defined radio, is if you save up on and don't want to spend a lot on a software-defined radio as a module itself, I would really encourage you to invest into good antenna, because you can have a really expensive module with very bad quality antenna and you won't get good results, and it's just a lot of interference and not quality measurements. So yeah, invest in a wide range antennas and buy a good quality one which will last you for a while. And the last few things I want to mention is that you can use it as a police radio scanner, listening to satellites, radio astronomy, monitoring meteor scatter. It just list goes on and on. Watching analog broadcast. And yeah, that's about it what I wanted to talk about for today. And if you have any questions here in person now or in the chat, I would love to answer. Yep. Yep. So as we can see, we don't have many questions in the chat. And do we have anything in person which would be of interest? Huh?
How do they keep you away from doing any of this?
Any of this. So basically, as we said, we would encourage doing this on the things you own yourself, but I mean, not all people earn satellite, as we know, but you usually can listen to everything you can get to your device, but you're not allowed to transmit, and some of it are encoded, so you can't really understand what is that noise. So that's how it works usually.
No, but I mean, how do they keep you away from
I mean, technically, there's nothing stopping.
Yeah, technically there's nothing stopping.
Laws.
Yeah, other than laws as a radio frequency.
People say go into a field, but I mean that's not the most practical.
Yeah.
Yeah. So there's a lot of things you can do, but yeah, just your creativity is the only thing that's stopping you. And yeah, thank you for watching, and till the next week. Oh, and we're doing a bit of a break, the Christmas break. Yeah.
I thought this was the last week.
It is the last week.
Yeah. So this is the last week, and yeah, thank you for watching. Have a wonderful evening.